Hi, my name is Matt Nicholas and I'm a process engineer in the Hot Runner R&D lab. In this video, I will be introducing and explaining the details of the Sidegate Inline product. We will review the key features, specific components, and assembly and maintenance process for this technology. This product is an evolution of the original Sidegate technology that will allow customers to increase cavity density for a given footprint. The design also allows for the desired inline cavity layout that is common in small part molding. The Sidegate Inline technology includes the same cavity interface and standard tip configuration as the original Sidegate product. The Inline design allows for cavity pitch of 18 millimeters up to 35 millimeters, and the initial product will include two standard pitch nozzle heads, 18 and 25 millimeters. Before we begin, let's get familiar with the Sidegate Inline components and terminology. The Sidegate Inline uses the same nozzle tip assembly and gate detail as the original Sidegate product. There are 4 cartridge heaters for every nozzle head. Depending on the customer configuration, there will be either 1, 2, or 4 TCs per nozzle head. A 24 millimeter retaining nut secures the nozzle head to the nozzle housing. A split ring provides the necessary backup for the retaining nut. The nozzle head provides melt distribution from the nozzle housing to the nozzle tips. There are some uncommon tools that will be necessary for assembly and service of the Sidegate Inline product. The first is a 24 millimeter crow's foot. This will be used to properly torque the nozzle head retaining nut. The second is a split collar. This is used as a jacking feature when removing the nozzle heads for service. The tool gets applied behind the retaining nut and jacks the head as you unthread the nut from the housings. Next, we'll be discussing assembly of the nozzle head to the nozzle housing. Nozzle head installation consists of the following components: the nozzle head, the nozzle housing, the split ring, and the retaining nut. Apply nickel anti-seize to the threads of the nut. Prior to installing the nozzle head on the housing, you will want to slide the retaining nut onto the housing as well as install the split ring. You will notice that there are flats on the nozzle head interface that correspond to flats on the nozzle housing interface. These flats provide the nozzle head orientation and prevent the head from rotating during installation and removal. The nozzle head heaters and TCs are small components that will require some patience, and in cases of tight pitch applications, a strategy for a clean installation. First, we'll review heater and TC installation in tight pitch applications. The nozzle heaters and TCs in tight pitch applications should include installation of the components at the neighboring locations before installing the nozzle head. This is done due to the lack of access to these installations once the nozzle heads are installed. First, we will install one TC until the locating crimp bottoms out in the TC counterbore. Keep in mind that the TC installation is at a compound angle, so you will need to angle the TC accordingly during installation. Then we will thread a cartridge heater through the eyelet in the TC tab and into the heater bore in the nozzle head. The heater should be inserted until the flange bottoms out on the TC tab. Once the flange has captured and loaded the TC tab, the set screw can be torqued to 25 inch-ounces. We would do the same for the heater and TC in the adjacent location on the nozzle head. At this point, we are ready to install the nozzle head onto the housing. We will leave the remaining 2 TCs and heaters until the head is installed and torqued. Align the flats on the nozzle head to the flats on the nozzle housing and seat the head on the housing. Slide the retaining nut forward and thread onto the nozzle head. Torque the retaining nut to 35 foot-pounds. Install the remaining 2 nozzle head heaters and TCs. On tools with a larger drop-to-drop pitch that allows for access with your hands, you can first install the nozzle head, torque the retaining nut, then install all cartridge heaters and TCs last. Disassembly of the nozzle head components isn't something that will be required on a regular basis, but when necessary, should be simple when using the correct process. Whether in the press or on the bench, simply removing cartridge heaters and TCs from the nozzle head will allow access to the retaining nut for removal. Before completely loosening the retaining nut, apply the split collar, which aids in breaking the plastic slug and safely pushing the head off of the housing. Keep in mind that removal of the nozzle heads could cause rotation of the nozzle housing on the anti-rotation dowel. This will require the standard side gate assembly procedure of the cavity plate to ensure that the nozzle heads realign with the nozzle tips during reassembly. One of the key advantages of the Husky inline side gate is individual tip control. This allows the processor to individually manipulate tip temperatures to help overcome inherent molding challenges. During lab testing, we were able to improve balance by up to 40% on some applications with a tip temperature delta of 15 Celsius. The effectiveness of individual tip control can be limited by certain applications in a maximum delta of 15 Celsius for a given nozzle head. On a new tool, installation of the cavity plate should be done according to the standard side gate installation method. This includes rotation of the cam jacks to remove preload from the nozzle housings. It is recommended that the mold be designed such that the cavity plate is installed with cavity blocks removed. Then cavity blocks can be installed individually, one at a time, to ensure nozzle head to tip alignment, thus preventing damage to the tool. Removal of the gate blocks may be necessary in the press for tip cleaning in the event that contamination enters the melt path and obstructs flow through a tip and/or gate. Ease of gate block removal will be dependent on the mold design. It is recommended that the mold be designed with a jacking feature for removal of individual gate blocks. A jacking fixture may be the best approach for clean block removal. We hope that the details and recommendations described in this video help to ensure successful assembly, startup, and maintenance of the side gate inline product. Thank you for watching.